All right, lesson 52. In lesson 52, we're going to be writing the equations of lines given 2 points on the line. Now, we've done some of this. We actually did some of this on the last test using the slope-intercept form of a line. If we knew the slope and we knew the y-intercept, then we could plug those two values in and write the equation of the line. And we did that from a graph. All right, we did it from a graph. And we did it from other given information. If y'all recall the homework problem on the biscuits, and the homework problem on the cat food, right? Those two homework problems both involved finding the y-intercept and finding the slope and writing the equation of the line using those two pieces of information. So we've done this with the slope and the y-intercept, but we have not done it just given 2 points. All right? Now, it's important here, and this is very ACT important. It's very important that we know and are familiar with all three forms of a linear equation. All right? What is the standard form of a linear equation?
AX plus BY equals C.
AX plus BY equals C. And what were the conditions on A, B, and C?
A can be negative.
A, B, and C are relatively prime integers, right? Relatively prime means that they do not have any common factors. Integers means they cannot be fractions or decimals.
Like C can't be 0.
And A cannot be negative. And A and B can't both be 0, right? If we don't have an X or Y, then we don't have a linear equation, but that's... Right, so that's standard form. A, B, and C have to be relatively prime integers where A is positive. AX plus BY equals C is standard form. All right, what's the other form of a line that we know so far? The slope-intercept. The slope-intercept form is what? Y equals mx plus b. Y equals mx plus b, and in this formula, m is the slope, and 0b is the y-intercept. All right? All right? And that's really, kind of, you need to know those slope-intercept form and standard form. We've talked about both of these pretty extensively up to this point.
What does the slope formula fall under?
The slope formula is just a formula for finding slope.
Okay.
Now, there's going to be a correlation between that and what we look at today, and I'll show you that in just a second. Today, we're going to look at the point slope form. Point slope form. Okay? Does anybody know it?
Like Kara's just talking about it while she's a little bit.
Yeah?
You remember her talking about it?
Yes.
It's a big deal. We're going to do this.
I mean, I've heard, like,
from
the
here
name,
moving
but I don't know
forward,
what it
we're
is.
going to do this skill a lot.
I've heard it from
I've never.
You'll do it in geometry. You'll do it in Algebra 2. You'll do it in Trig and Pre-Cal. You'll do it in college algebra. You do it in calculus. This skill, this point slope form, using this point slope form carries through all of the rest of your math life. It's a big deal, okay? Factoring. The factoring that we've done so far, it's huge. The point slope form is y minus y1 equals m times x minus x1.
What?
All right?
May you write it? Because I don't think it. You talk very fast.
I wrote it.
Y minus.
We have maybe
Why?
I remember
a
that.
breakdown between the whiteboard and let's try it again. Y minus,
Y1
no, it's not writing.
equals.
Pause.
It's better than the
Horrible. What's horrible?
You. Chuck's not even listening. Okay. Jack has no clue. Jack, what's the point slope formula?
You don't know it either.
I know the
What's
first
the
part.
All right. Y
Yay!
minus y1 equals m times x minus x1. All right. Now in this formula, x and y are variables, right? M is the slope, and x1, y1 is a point that the line passes through. Okay, now I want you to notice that these negative signs in the formula are important. You have to recall that if a formula has a negative sign in it, that means that the coordinates will change values when you put them into the formula, and they'll change values if you pull them out of the formula. Right? And here's what we mean by that. Y minus 3 equals negative 1/3 times x plus 2. That's point slope formula, right? Doesn't this look exactly like this? What's the slope of this line?
Negative 1/3.
Negative 1/3, and it passes through a point.
3, 2.
Negative 2, positive 3.
Because you got
Because if you put this negative 2 into this formula up here in the place of x, you get minus a negative 2, so it becomes plus 2. All right. So that's what I was saying, that the value will change signs going into the formula, and it changes signs coming out of the formula. All right, so we can get these two pieces of information from a line that's in point slope form, and we could use those two pieces of information to graph the line. All right, so you may be at some point asked to sketch the graph of a line that's given to you like that. We'll just use the point that they give you and the slope that they give you, start at the point and count the slope, rise and run. All right. Okay, so we've got that. But the primary purpose, well, let me show you one more thing. I want you to see this relationship. The slope is y2 thing is not cooperating today. Y2 minus y1 over x2 minus x1 equals m, right? Put that into proportion form, right? And watch what happens if you cross multiply. We get y2 minus y1 equals m times x2 minus x1. And if we just change the y2 and the y1 and x2 into variables, we have the point slope form. The slope involves 2 points. The point slope form only involves 1 point. But they are directly related to each other. The point slope formula is what you get if you cross multiply the slope formula and you only have 1 point instead of 2 points. Okay? And that's a big deal if you ever forget the point slope formula, but you can remember the fact that it comes from the slope formula, then you can get it. All right? Now here, the fact that we just mentioned in the previous slide here is that the point slope form will primarily be used for writing equations of lines. Now we can use any of the linear forms to write the equation of line, including the standard form. Standard forms actually, and I show my college algebra students this, there's a slick way to write equations of lines with the standard form equation of a line. It's really, it's pretty smooth. But we're going to use the point slope form because ACT is very advantageous to do it this way. So anytime you see the instructions to write the equation of a line, what is the equation of a line? Find the equation of a line. Unless they give us the slope and the y-intercept or a graph where we can see those two pieces of information, we're going to use the point slope form to write the equation of a line. All right? For example, as the name indicates, we use point slope form. We must have a point and a slope. Almost forgot something that is very important. If we're going to write an equation of a line, we must have a point and a slope. Not optional. You cannot write an equation of a line without those two pieces of information. Stop clicking. I don't want to threaten a child with bodily harm on a video, but that pin clicking's got to stop. All right. Example. Write the equation of a line. What are we being asked to do? Write the equation of a line. And I just told you that we're going to use the point slope formula to write the equation of a line, unless we're just given like the slope and the y-intercept. Then we'll use slope-intercept form. The slope of a line, it has a slope of 3 and passes through the point 2, 4. What two pieces of information are we given? A point and a slope, right? A point and a slope. And it tells us here that it wants us to write the final answer in point slope form. So that just gives us an indication of what the final answer should look like. And that's where the ACT gets tricky, okay? I have seen ACT questions where they ask you to write the equation of a line, and there's 3 correct answers in different forms. So you have to pay attention to which form they're asking for it in. And a lot of students will just jump on the slope-intercept form because that's what they're used to, and they'll find the slope-intercept form and choose it, but it's not the form they're asking for. They may be asking for it in standard form, or they may ask for it in point slope form. What's your question?
Okay, so you know how it's like y minus y1?
Yes?
So how do we know which y to put the point in?
It's the one that's subscripted.
Okay.
The x and the y
Stay the same.
are variables. This is the variables.
Okay.
That's my x and y that's going to be in my linear relationships. Okay, the x1, y1, these two quantities, that's our point. This is the slope. So those are the 3 things we'll always be making substitutions for. We're always looking for a point, and we're looking for a slope. All right, our point is 2, 4. So I have y minus 4 equals 3 times x minus 2.
If it was negative, if the 2 was negative, then it would be x plus 2.
Yeah, that's right, because it's going to change signs going into the formula, and it changes signs if we pull the information out of the formula as well. Now, from point slope form, this is one of the great reasons that I always use point slope form to write equations, is because it's very easy to change it into the other 2 forms. First of all, it's easy to use, right? You just plug the values in. You don't have to plug something in and then find something else, like you would if you used y equals mx plus b. We can quickly distribute the 3.
3x minus 6.
Add 4 to both sides.
Oh.
What do we have? Slope-intercept form.
Nice.
Okay? From there, I can quickly subtract 3x from both sides. And then what?
Then you've got the thing.
Change all the signs, and we have standard form.
That was cool.
All right? Now, I want you to imagine what it would look like if you used the slope-intercept form, this one, and went straight to this answer. How would you change it back into that answer if that's what the ACT was asking for? You can't do it. Or if you use that the obscure method that I mentioned earlier, to use standard form to change it back into that form, it's very difficult. Right? So the reason I like to use point slope form is because it's very easy to move from one form of the linear equation to another form of the linear equation using point slope form. Okay? All right? Any questions? Now, the correct answer for this one, point slope form, is right there. All right? Next example. Write an equation of a line that passes through the points 1, -3, and 4, 5, and they want our final answer to be in slope-intercept form. So that just means we want our final answer to be y equals mx plus b. But anytime we see these instructions, write an equation of a line, what are we going to use? We're going to use the point slope form, and we're looking for a point and a slope. Why do we need a point and the slope? Because we're using the point slope
So what if there's no slope?
form.
We have to find it?
If there's no slope, then we need to use the information that they gave us to find it. I'm never going to give you a question that tells you to write the equation of a line where there's not enough information there. You're always going to be able to find the information that you need to write that equation of a line. Okay? So in this case, we need to find the slope. The slope of this line is equal to the change in our y values over the change in our x values. That's equal to -8 over -3, which is 8/3. Now we need to pick a point. Which one do y'all want to use?
First one.
First one? Numbers are a little smaller if we use 1, 3. 4 and 5 are larger numbers. So let's do y minus -1, y minus -3, that's y plus 3, right? Equals 8 over 3 times x minus 1. That's the point slope form, right?
I put it in line.
We got to put it in slope intercept form, which means we need to get y by itself. So I'm going to distribute the 8/3. Don't get intimidated by fractions. At this point, you could multiply through by 3 and get rid of fractions. Then we'd have to divide through by 3 at the end. So let's just work with them on this one. The next thing we need to do is subtract 3 from both sides. 3 is how many thirds? 9 thirds, right?
Yeah.
So we got -8/3 and -9/3.
You got -1 there.
So I have -8, -9.
Oh, just
Same
make it
signs,
look
add
like-
and keep. Different signs, subtract. Okay. Y equals 8/3 x minus 17/3. All right. Now, what if Caroline chose this point and Charlie chose this point? It should, shouldn't it? Because there's only one line that has that slope and that y-intercept. Well, let's go back and test that theory, right? Let's test the theory. Y minus y1, that's y minus 5 equals 8/3 times x minus 4. You don't have to write this down. Y minus 5 equals 8/3 x minus 32/3. Add 5 to both sides. 5 is how many thirds? 15/3. Positive 15/3. So -32 plus 15 is -17/3. So we get the same answer regardless of which point we use. Now, the point slope form answers were different. And that's why if you're given 2 points, you're almost never going to have a standardized test that asks you for the point slope form if you're using 2 points, because there's 2 different answers. But slope intercept form and standard form are always going to be standard, the same. All right. Okay, next example. And one more after this and we're done.
Cool.
All right. She sells seashells by the seashore. Can you imagine a much worse place to sell seashells?
Like, use the hollow ocean.
Just go over there and pick some up. I'm not going to buy them from you. Come on.
Unless you're lazy.
All right, this is Rachel selling seashells by the seashore. She sold 1 for $5 and 2 for $8. What will Rachel charge for 5 seashells if she keeps selling the seashells at the same price rate?
Where should find the price rate, right?
Yeah, the rate is the slope. That's right. So what is the slope of this relation that's going on here?
It's gonna, yeah.
It's going to be 8 minus 5 over 2 minus 1.
3.
That's equal to 3.
So she increases by $3.
That's all we have to do.
No,
Oh,
we want to know how much she's going to charge for 5 seashells.
That'd be $15.
Oh, yeah.
Plus 5, because that's the base rate.
You have to multiply by 3. Wait.
All right, now there's a couple of ways we can do this. We can do this, right? 1 is 5, 2 is 8, 3 is 11, 4 is 14, 5 is 17. Okay, so that's one way to do it, right? We could also take one of these points that they gave us. Y minus 5 equals 3 times x minus 1. And plug in 5 for x.
How do you know which one to plug it into?
Because of which one is independent and which one is dependent.
Oh.
Cost is dependent upon the number of things. So this is y and this is x. So that's 12, right? Add 5 to both sides. We get 3 times 4 plus 5, which is 17. So when we sell 5 shells, it costs $17. Now, this works, and I would take that if you showed me work that led to that answer, show me that logic. But here's the deal. What would 27 seashells cost? And would you want to continue this pattern all the way up to 27? No, it'd be quite a lot actually.
Could you do the,
It's 3 times 27 plus.
A sub n equals A sub 1?
Do what?
Could you do that thing?
Actually, I think it's 83. Yeah, you could actually use a sub n. Common difference is
Because that makes a lot more sense.
the common difference is
3.
yeah, right. So let's have a look at what that would look like if we wrote this as a rule. A sub n equals the first term, right, which is 5
Yeah, 5.
plus n minus 1 times 3. Now, hold on just a second, and let's have a look at what that would look like if we just move the 5 over.
Oh, it's the
That's
same
what I was
thing.
thinking. Okay, that's what I was making the connection in my head
Oh my
too.
goodness.
And then she asked about
Change this to y and change this to x.
So awful.
it.
And that's the
There's
same
variables.
equation that we just looked
I'm
at.
so dumb.
So because these arithmetic sequences are linear expressions, they have the constant rate of change, so they're linear. So we've done some forms of this already. You can see the relationship between these two things. Excellent, you guys are thinking today, and I love it. I love it. Write the equation of a line that has a slope of 6 and passes through the point 7, 9. And we want it to be, our final answer to be in point slope form. Now, anytime it says write the equation of a line, we're going to use point slope form regardless of what they want our final answer to look like. This is where we're going to always start to write equations of lines. So if it says write the equation of a line in the homework tomorrow, find the equation of a line. What is the equation of a line? They're all asking us the same thing, right? Y minus y1 equals m times x minus x1, and we're looking for a point, and we're looking for a slope. The two pieces of information that we have to write the equation of a line. We got a point right here. We got a slope right there. So y minus 9 equals 6 times x minus 7, and we are done. Okay. Now, if they wanted us to write it into slope-intercept form, we could do that. We could write it in standard form. Whatever form we want to put it into from here, we can do it. Just distribute the 6 and move things around. All right? This will be our classwork tomorrow. Go ahead and write it down so I don't have to put it back up from this. Don't do this tonight. You'll have time in class to do it tomorrow.